All right, we're back, and we are COMP1004 in the fall 2016 semester, and it's week 5, part 1 of our broadcast for rapid application development at Georgian. Again, we're working in C#. I just did a bit of a check for people who are remote today about your project. I do see some people have put up their lab 1 up on Blackboard. The stuff I'm looking for you, if you haven't had a chance to finish today, and you're going to finish later on, is again your UI. Just take a screenshot of your UI. Get a link to your GitHub would be nice, so I can see what you're producing. And this would be the kind of stuff we're doing with our labs. I'm just checking to see if you guys are progressing, like a progress report. All right, so last week we kind of, I'm just going to launch this, my virtual machine while we talk, because otherwise. And by the way, I've changed my active hours, so you shouldn't do what it did to us last week, right? Just because of recommendations, right? I have to say, Logan, you're right. I'm recording this live, so it's forever, right? You're right, Logan, I was wrong, right? So I got to say that. But the active hours have changed to 8 o'clock, so we should be fine, all right? So there's no issues with it happening again. I feel a little embarrassed that it happened, but it is what it is, right? So as I launch that stuff, I'm going to talk about the PowerPoints a little bit first. So they're up on GitHub, on Blackboard, and there's a couple of them. One of them is how to use arrays and collections. So I want to kind of go into this a little bit, and I want to talk about some of the more important highlights about this kind of stuff. All right, one thing to note about C# is some of the syntax is a little funny when it comes to stuff. They do a lot of things like when you declare an array, and if it's an array, there's 2 ways of doing it. I can declare the type. Here's my type, whatever the type is. This is the general form, and then the array name. And then what I can do is, in another line, I can say of a new type, here's my new array of whatever the length is. That's one way of doing it. You can also do the array declaration in one statement like this. So this is kind of fine to do in C#. Again, we're just talking about syntax. I don't expect you to not know what arrays are at this point. You should know that they're like matrices, if you will, or a collection of data. Usually the collection is the same data type in C#, okay? And I say usually because you can have arrays of objects as opposed to just arrays of primitive data types like decimals and integers, as an example. Okay, so here's some examples of this. You have a decimal array that you're declaring that's called totals. And then what you're saying in the new line is totals is equal to a new decimal of 4 elements. That's what you're saying. So 4 spaces in the array. And this is a single dimensional array. So it would be a matrix, if you will, if you go back to, high school math, a matrix of, kind of a 1 by 4, right? So, or is it 4 by 1, right? 4 by 1 matrix. Doesn't matter, same thing. And that's what it is, right? And again, so with one statement, you can do it this way. So again, both ways, this way and that way is correct. Again, just highlights of this kind of stuff, okay? An array of strings. So I'm going to do a string type of array, and then it's very similar to the way it is for decimals, okay? Default values for array elements. This is important to understand. What's the default value if you don't initialize on an element in the array? By the way, it's a little different in some languages. So if it's a numeric data type, then the default value is 0. So you don't have to initialize something to a 0, like for example, an integer, or some kind of real data type, like for example, double or decimal or float. If it's a character type, it is the null character, which is \0. That's the null character. If it's Boolean, it's false. If it's date time, then it's 01010001 back to the year 1, right? Which is way back when, 2016 years ago. And then reference types are null. Reference types would be objects, classes, other kinds of things like that. Strings are reference types. Other arrays, right? Those kind of things would be null, right? So that's an important thing to understand when you declare stuff. So when you initialize arrays, this is the same kind of syntax that we've seen in other languages. Okay. There's different ways to initialize arrays. You can do it explicitly like this, right? So where you actually assign a value to the array. So here's the value in the literal, the value on the literal on the side, and you notice that we have the type that's next to it. For M would be decimal. We use these markers in C# to denote that it's a decimal number as opposed to double or a float, right? F for float. Double would be nothing, because double is the default, right? And then, so those are these, right? As well as, that's one way of doing it. You can also initialize. This is the initializer methodology. So you can actually have my decimal, which is totals, right? That's the totals array, which is a decimal array. And then we initialize the array with values inside curly braces. This is kind of the initializer syntax, right? So those two ways of doing it. If you really want to, you could also use the new new keyword, and you don't have to declare the type. And this is a way of inferring the type by what you're storing inside the array, right? You might see this as loosely typed. It's not loosely typed, all right? It's just the var keyword is telling C# to say, well, we don't know what grades is right now. It's a container. And while we're filling it with what looks like integers, so chances are it's a new array. That's what the syntax is. A new array of integers. That's what it is. That's the syntax. Would you do it this way typically? Probably not, right? But can you do it this way, especially when it comes to dealing with some issues? Remember, C# and other languages, they have many ways to do the same thing to help you get around problems, right? And that's why that exists that way, as well as other kinds of solutions, neat little solutions. Okay, one of the most common properties of arrays in general, actually, and other structures are the length. It's a length property. If I want to know how long the array is, how many characters are in it, or how many elements are in the array, it's length, the length property, right, which is important. Now, it's different than generics. Who knows what the similar method is in generics, so like something like a list? Anyone knows that? I'm just putting it out there. We're going to talk about it today anyway, even if you don't know. It's count. It's instead of length, it's count. It's just another word, right? And we'll talk about what the difference is between a list and an array. There is a difference. Okay, so typical arrays, the length property counts how many elements are inside the array. That's what this does. Very, very useful property. And why? So we can do a really bad for loop like this, right? Why is this a bad for loop again? Because there's no, curly braces. That means that this number string, which is plus or equals to this string, and if I add something else under here, let's say, for example, if by accident the user was to shift this message box.show method that looks like it's aligned underneath the for loop, they may think that the for loop is going to go through and include the message box, but in fact, all it's going to do is hit the number string, right? That's why we don't do it this way. But that's what we do. We look at the numbers.length, the length of the array, and then we loop through just like we do in other languages. So very, very simple. Okay. I'm not going to talk about that, and I'm not going to talk about this. Just examples of how to do it. Same thing with the for each loop is probably the most common way of looping through an array or some kind of collection without using an index, right? So again, how do we do that? We use, for whatever type the array element is, example, for every string in strings, if it's a string type array, then we do a bunch of statements. And here's a good example of that. For every total in totals, for each total in totals, right? And when we say total, for each decimal value that's contained in the array of totals, right, we want to add the total to the sum, right? So we're going to get the value of that of what's contained in each of the cells through each iteration of the for loop and transport it or assign it or add it to the value of the sum. Okay, so very similar stuff. So a very common looping structure that we use for each. We're not going to go through that too much. This is different. If you notice, we have an array here, and the syntax for creating a rectangular array. Well, there's a difference between an array of arrays and a rectangular array in C#. Okay, again, we're talking about syntax here. That's why I got to talk about it, so that way, if I ever talk to you in a test and I say, what's the difference between a rectangular array and an array of arrays? What's another word for an array of arrays? Anyone know that? What's that? This is a two-dimensional array. So this is kind of a multi-dimensional array right here, right? There's different ways of doing this, but an array of arrays actually in C# is called a jagged array. That's the actual name for it, right? You may have not heard that term before. You may have heard that term before, but they're called jagged arrays because you can have an array of arrays. It doesn't have to be necessarily that each array inside the array, the main array will hold a bunch of, in each cell is going to hold other arrays, right? Doesn't mean that the arrays inside the cells are of equal length. So therefore, it's jagged. It can create an array with a bunch of different length cells, which is different than an array, a multi-dimensional array like this one, two-dimensional array in this case, which is a 3x2 array, right? That's what this thing does. And this, what you're doing here is saying how many elements are in rows and how many columns do we have. So rows and columns, right? I'll tell you right now, I almost never use this structure. You know why? I can do everything pretty much in a single dimensional array. It's much easier, and it's a lot of times more, a little bit quicker. Also, I avoid arrays like the plague in general, right? I usually use lists when I program. Why? Because they're more fluid, right? Not to say that these structures aren't valid or they have no use. There's lots of uses for arrays. In fact, all the stuff we do with lists are basically arrays in a different way, right? We'll talk about that in a second. So again, do I use this a lot? No. But if you really want to represent in your brain a matrix that's, let's say, of 3 columns, 3 rows by 2 columns, this is a great way of representing that. So if you have a math problem and you want a physical representation that's closer, it's this. And they give you examples of the positions of the array. In this particular case, like a 4x4 rectangular array. This position here on the top left corner is 0, 0, and it's like we normally see in a matrix, right? Which is what this is, right? Matrices. If you look at math, this is a great way of understanding what that is. Okay, as we go forward, you can see that it gives you examples of how to initialize a rectangular array, which is very similar to the way we initialize a regular array. You can do it 2 ways. You can actually put the values in there. You can assign it through a for loop. There's many ways of doing the same thing. There are some special methods that are aligned with rectangular arrays, though, I have to say. Again, specific to C#. So now we're talking about specific syntax, C# only. GetLength, right? What GetLength does is it gives you the length of either the rows, number of rows, or the number of columns in your rectangular array, right? Sometimes it's important for you to understand what that is, right? Especially if the array has been declared dynamically. So I haven't assigned values to it through a loop structure. I'm assigning it, by it's kind of creating the size of the array when it's being created. But I want to know how big the array is. I can do that by saying getLength. If I put the 0 in there, it means it's rows. I'm checking how many rows are in there. And if I put a 1 as an argument, I can check to see how many columns. So that's a different method that we use. I'm not going to go too much into it. There's lots of little methods like that that are specific for rectangular arrays and nothing else. I'm going to kind of skip forward here into other kinds of array. Here's the jagged array. So this is kind of something where you were thinking about a jagged array of where you have an array of arrays. Or that's a different way of doing things. So when we declare an array of arrays, you can see that this is one way of doing it in here. So I have an int, and you have 2 square brackets, 2 sets of square brackets, right? So an array of arrays. Very complex sometimes for people to comprehend, because you have to picture that each cell itself is just, or each again, a much more complex structure. We reserve this kind of stuff when you need this kind of representation. Sometimes when I do this kind of thing, I'm thinking about grids. If I do a 3-dimensional grid or something like that, I might use an array of arrays. And why? Because the array that's contained inside my array would probably be representational of a 2-dimensional grid, 2-dimensional like orthographic view. So maybe, for example, I have X and Y in the array that I'm containing in my, the array container, right? Again, different ways of thinking about this kind of stuff, and it can boggle your mind if you think about it too much. It can be confusing for you. For some people, it's easy to understand because it's just one container and there's other containers inside the container. That's what I want you to think of it like. Am I going to get you to do jagged arrays, as an example in this course? Chances are not, right? However, what I will do is I'll ask you the difference between a jagged array. I'm telling you right now in advance. If you want to study what you want to study for your test, if we do a test, if you say what's the difference between a jagged array and a rectangular array, you should know the difference. Rectangular array, multi-dimensional array. Jagged array, we probably talk about it being an array of arrays. Okay, that's the only difference. Well, there's big differences there, but that's the differential. All right. Okay, and then we give you the general form. By the way, an array of arrays, you can have you can go as many deep as you want, which becomes very complex, right? Be careful, it takes up a lot of memory for you to do this. And so computationally, it's expensive to do arrays of arrays, especially if you're going and you put them in a looping structure. Very complex, and they can be very complex to understand, right? So remember, as programmers, we want to kind of make it as easy for other programmers to understand what we're doing. And we use complex structures, especially when you have arrays that are nested inside of other arrays. It becomes it could become something that looks very complex. Okay, moving on. So it talks about different properties for the array class. You can use the array class itself as a static class to get the length again. And there's other things we talked about as well. One of the things I like to do with arrays is create a sorted array, right? You can actually, create a sort. You use the sort method on an array, and it returns a one-dimensional array that is sorted in ascending order. Sometimes this is really important for us to do. Example, if I want to do something like, I want to get the names in sorted order, right? With an array, we use sort. That's good that we have that methodology. One thing that's missing that we don't have in C# that we do have in Java, which it kills me, is the shuffle method. We don't have the shuffle method in lists and arrays. We don't have that at all. And we'll talk about that as we go forward. So if I want to make a card shuffling program, which we're going to talk about how to do a card shuffling with C#, it's way more complex because you have to kind of create everything by hand. Okay, let's move forward. So the sort method, all this is doing here in the book is talking about different methods and what they do. For example, binary search. If you want to search for an employee, a specific employee inside the employees array, you can use the binary search method to do that. Okay, and there's lots of stuff that it covers. Again, nothing that you shouldn't have seen in Java. You guys should have seen sorting and searching, all basic stuff that we're covering again here in C#. Okay, just want to get to collections because the rest are pretty much the same. They just go over more and more examples here in the book about what is being covered. Right, so if I'm skipping through here like this, again, I want you to know that I'm not going to really cover it at length, when it comes to what we're doing. I've talked about it, but you should know basic structure, basic syntax is what I'm looking for. This is something new. The null, if you want to create a null array, right? In C# 2015, they give you the ability to use the question mark operator. Remember we talked about this as something that we look at as optional question marks, right? The question mark operator says, hey, you can test to see if a value is null, right? Otherwise, it's going to return something called a null reference exception, right? So to avoid null reference exceptions, in C# 2015, they created this null conditional operator, right? We're not going to go too much into this again, but I just want you to recognize that when you see something like this structure, it's valid, all right, in C# 2015, right? So this means, hey, you know what? My initials, the 0th index of the initials array, right, could be null. And if it is, don't do the 2 upper. That's what it means, right? So it's optional. If this exists, if the initials, the 0th element of this array exists, then perform, kind of put everything into the, because it's a string type, make everything uppercase, right? If it exists. If it doesn't exist, forget it. So instead of doing if statements and checking, you can do it in one line. It's a very useful little thing that they've introduced. Okay, this is where I really wanted to get to today, which was how arrays and collections are similar and how they're different. I want you to think about collections they're classes in .NET, in the .NET framework, right? And arrays are structures. They're actually a structure that's part of the C# language. Actually, it goes all the way back to C, right? Lists didn't really exist in C or even C++. They got added in later, right? In C, classic C, like we're talking about, there was no list. There was just an array structure, right? And the way I want you to think about lists are, they are almost like we created linked lists in C and C++ by using pointer constructs, right? And that's what we did, right? We don't have that in C#. There are, but they're not quote unquote any pointers necessarily in C#. But you can use references to do the same kind of thing. But what they've done is that computer scientists wanted to simplify. So when they created Java, we're talking many years now, and similarly when they created C#, because Java was so popular, C# is Microsoft's answer to Java, right? And again, Java would be the king of all languages. If you want to make a lot of money, Java, right? C# is still progressing and it's still popular as a language. But again, I would say Java is the more practical language to learn when it comes to making money. So C# and Java, they were created, and a lot of the constructs were added in. For example, things like generics and collections They were added in to make life easier for the programmer because these are tasks that are repetitive. Why am I going to make a linked list or a stack or represent something in a stack or some kind of queue where, by hand, with C, when I can have that structure already existing in my language as part of my library? So I'm using an existing library. It's been written well by a group of expert programmers, and all I'm doing is reusing the structure as opposed to me to create it from scratch, right? So that's where it came from. Okay, so the difference between arrays are fixed size, collections are variable. When I make a new list, this is the point, I want to point this out because we're going to do some list stuff today too, right? If I make a new list in C#, what's in the list? I make a new list. What's in the list? Yeah, nothing, right? And again, if this is just review for people who've done lists in Java and other languages, if I make a list, it's just a container, right? So think about it, it's an empty box, right? And then what I can do is I can use, instead of having a list of a bunch of, let's say little components or little rooms inside this big container, little smaller boxes in the big box, which is like what an array is, right? Containers within the container, like elements inside the array. A list is just a big empty box, right? And when you add stuff to the list, you add it in the list, and it, inside the list, depending on the order that you add it in, right? It adds it into that particular slot. But you don't know how big your list is going to be. So the list can be as big as you want. That's good, right? So it's more dynamic. I can add to the list, and I can remove items from the list, and I can sort the list, and the list can be empty if I really want it to be again. I can add stuff to the list and remove everything from the list again. That's a great thing. So that's a great structure that we've added in these modern languages. And by the way, even JavaScript has almost like an array list kind of structure. Same thing with Python. Array list as opposed to just strict arrays, right? You can do a lot of things with these modern languages that are very list-like as opposed to array-like. So when one of my colleagues says to me, Tom, we never use arrays anymore when I work. I always use lists. And it's not wrong because it's quick, it's easy. And there's some great methods that help you create the structure that you want that's very array-like, okay? I'm not going to tell you that it's the only way. So here's the list. So you have this list, and again, you notice that this .NET 1.0, this is what it used to be, 1.x, array list, it was what it used to be called. And now they're just called list. And if you notice, there's these angle brackets when we declare a list type. I just said it, list type. T, the actual value T, if you ever see this up online from a documentation perspective, T represents the type. So if I'm talking about generics now, right? I don't know what list I'm going to make. I'm going to make a list of some kind of type, right? So one thing I have to specify in C#, right, is the type of list that I'm creating. Is it a list of strings? Is it a list of integers? Is it a list of whatever, just like we do with arrays? I could also make it a list of cards or airplanes or a list of whatever, a collection of items that are similar. That's what they have to be, right? So that's the way we do it. We declare the type inside the angle brackets. And by the way, the most modern, JavaScript languages, for example, things like TypeScript, if you're a TypeScript person, and if you've been with me and we've done TypeScript together, TypeScript is being used, and they use the same structure, right? Because we use the angle brackets to denote the generic type that we want to use. There's also another structure called the sorted list. Again, not as used, but the great thing about this one, it has two values that you can put in. It's the key and value pairs. This is a kind of a key value pair list. So you have a key, like for example, the name of a property, right? And then the value of the property. Name of the property could be something like text. And the value could be hello world, right? So, and then this sorted list might have, the structure might be, the key would be strings, and the values could be integers, as an example. Or it could be the other way around. It could be integers as the key, so 1, 2, 3, 4, 5, 6, and then the value is the student name or something like that. Either way, there's some really good constructs that exist in C# that we can use to build as building blocks to build more complex structures, is what I'm saying. Okay. Also, some of these old holdbacks. Sometimes we want to represent a list as a queue. Now, what's a queue? Who remembers what queues are? Yes. First in, first out. Different structures in order for us to manage inserting and deleting from a list. Still a list type, right, or a generic type. You still have to specify what type, what kind of value you're putting in there, whether it's strings or integers or decimals or whatever, or cards or airplanes or whatever it's going to be that you put in there. You can still do that. but the sorting and searching methodology in queues and stacks are a little different. I want you to think about a queue as a line. It's a lineup, right? I'm lining up, and the first person that's in line is going to be the first person's out, right? First in, first out, right? First come, first serve is what I always like to think about when I look at queues. What about stacks, right? Stacks are a little different than queues. Stacks, I want you to think about like a stack of cards, right? That's a little different, right? I don't take from the bottom of the stack. I don't do that. I take from the top of the stack, typically, right? So it's, you know, and I want you to put this in there. So if I put last in, it's going to be last out, right? Last in, last out kind of thing. It's not first in, first out. It's a little bit different. Stacks are used for different methodologies, and sometimes we can use stacks to represent things like memory, right? Memory allocation and so on. For example, we're going to talk about the stack, how we use the stack in C# and other languages, right? Because there is a memory stack that we use, and this goes back when I use the word stack. Man, it goes back all the way when I learned assembly language way back in the day, right? Because we use stacks we use something called the accumulator, which is something what we I had bad dreams about loading the accumulator. Go. Assembly, like the original way back in the day 01 hexadecimal. For what? Oh, it's for Commodore PETs, buddy. I only had 4K of memory to work with, which is, thank God I only had that. And we made a Space Invaders game. That was good, right? Try and make a Space Invaders, yes. Space Invaders in assembly. It's insane. It took me all summer, right? It was a summer camp. Yeah, it was fun. It was lots of fun, and I was really confused a lot of times because I was only 10. Okay, but so that's what. So again, there's some really cool operations for lists, and one of them is this add operation. So I want to add an element to the list. So I've got this empty container, which is the list container, whatever it's called. Let's say, for example, I've got this deck of cards idea, okay? And I have a card class. The card class gives me a card object. The card has two properties, the face and the value, right? And I have a list of cards, which is the deck, list of cards. I want to add a card into the list. I can do something like, I can use the add method to add a new card into the deck, right? That's what it does. So the deck originally is just a container, or the list is a container that's empty, and I can add stuff in there. I can just, almost like a chest. Like I'm going to throw stuff inside this empty container, and it's going to fill up with stuff. But the container is like a bag of holding. You know, if you're a D&D fan, it's forever. I mean, you can keep on putting stuff in the container, and it's not going to add any weight. Well, actually, it does add weight. It adds memory. So the bigger the container, the more computationally expensive it is. Okay, so that's one way of doing it. We can still use the for loop, and notice that I'm using the count, like I said, the count method, the count property, as opposed to the length, like we did in array. So count is for lists, length is for arrays, okay? That's a good test question. So if I was going to say, if I was going to match up count, the two properties, count and length, match them up with the different structures, array or lists. Again, that's a good test question for you guys. It might be on one of your little true, false, multiple choice, multiple match, or whatever it's going to be. All right, so this is the way it is. Now notice what it says here. It says this will cause a runtime error. Why will this one cause a runtime error? Because we're making a new list of numbers, right? Numbers, chances are some kind of integer. We don't know what the number, the array list type is. We don't know what it is, right? And because this is just general form that we're looking at here. And when we add numbers, if I try and add a string, it's going to give me an error, right? Because you can only have all lists and arrays. They all have to be the same type, okay? Just like normal. Let's follow that methodology. Okay. And again, here's the real way of writing it. This is the actual syntax. So if you ever see this syntax, we're going to talk about this. It's like this. I need to use the list keyword, angle bracket, the type int, the name of the variable or the container called numbers, and the new keyword, which is a new list of integers with open and close braces, right? This is it. This is the syntax. Yes. Yeah. Yes, you can do somewhat like that, but numbers, you wouldn't do a numbers class necessarily because numbers is more primitive. You would kind of build your own class and have different properties, and you can use that one to create a list of, right? A list of whatever the class you made. Maybe it only has one property, which is an integer. That's the way you do it. Okay, so Again, very basic stuff. You may have seen this structure before in Java. Who's seen this structure in Java before? This kind of structure. Okay, good. I'm happy that some people have seen it. Some people may not remember it. Maybe that your Java classes kind of glossed over it because remember it's generics and lists are kind of more of an intermediate kind of topic. We're going to use lists in this class because if I have a pull down, like if I create some kind of control, drag and drop a control onto my Windows form, and it's a pull down, it's a list, right? If I make a grid that connects to a database, it's a list, right? And there's many other kinds of lists here that that we're going to be using. So I want you to think about it. If I want to know the length or the how many objects are in the list, we're going to use count, and it's going to be something we're going to do over the next week or so. Okay, so lists. Here's a string list and a decimal list and another string list. I mean, now you can also specify a capacity, but why would you do that? It kind of defeats the purpose of lists, right? Don't do this, right? Can you do it? Yes, you can. Should you do it? Don't do it unless you really want to limit the person to only 3. So now the box is smaller. You can only throw in 3 items. You can have 0 items, and you can have up to 3 items, but nothing else, right? Why? It's very rare that you'd want that, unless you're something like you're doing some kind of memory saving, like you're trying to kind of shore up your memory usage. You might want to do this kind of thing, but typically we do it like this. We don't declare the length of the list, or the capacity is what it's called, right? Okay, different methods that we're going to talk about. Yes. Well, it depends. If you're on a big machine like one of ours that we have right now, and I say big machine because it's like pretty much limitless with gigs of memory, chances are not going to make a difference. But on a device like this, yes, right? You want to think about memory management on a device still. At least only have maybe 2 gig, maybe, right? If you're lucky, and eventually it won't be an issue. Again, it'll go back. That's why we code so badly today. And I like your question. We code badly today because our processes are so fast. It can still do what we want it to do even through all our bad, brute force code, right? That's the reality, right? But in the past, like I said, we couldn't. We had to be really efficient because it was computationally expensive to be a bad coder. Nowadays, anybody can code, and as long as you make it work, it's okay because chances are, and unless you're in a code review situation where they're actually looking at you, it's okay. And it's bad to say this, but to make it work. Make it work. We don't care how, right? Here's something that I want to tell you. There's also this clear method, which removes all the elements from the list. So I want to empty my box. It's an empty container. I want to empty it. I use the clear method, and I just dump everything out. It's gone. That's a very valuable thing to do. Sometimes you want to reset everything, and this is the way to do that. For example, if I want to name a bunch of names, I want to add names and email addresses, I have something called a person object, and I want to have names and email addresses, which is part of the person object, and I'm adding people to the list, and then I'm done. I can dump the whole list, and all the people go bye-bye by using the clear method. Okay, so some very basic methods. Here's some more. Insert, as you would say, it inserts inside of a specific spot in the list. Remove, we can remove items from the list, right? And again, you want to search for an item, the first occurrence of the specified object. For example, if I'm searching for the number 1 and I have 5 ones in the list, it's going to take the first one, right? Or you can specify in a specific place in the list. Again, even though they're lists, they still have an order. Whenever the way you add things into the list is the way they're ordered inside as in the list itself. So I have an empty box, but as I start adding things in, I still can index everything in the list if I want. I can also use the sort method, which is also part of the array structure, all those basic things. Okay. Here's some examples of me, adding in a bunch of names, right? So I've got this element. Here's my string, a string of last names, right? And what I do is I have a capacity of 3, right? Remember I talked about this? Well, now I need more. As I keep adding names, once I go beyond 3, it starts adding names. It starts doubling. Yes. Okay, but it would take the first. So let's say, for example, if you were searching for the exact match, like first name, last name. Yeah, you just use remove, and it'll look for that object, right? Now the problem with that is depends on how your object is put in. If it's an array of strings, no problem. But what if it's an array of people? How are you going to remove? You got to tell it how to remove. And that's where where lists become very complex, because you can sit there and go, well, what do I look for in the list to sort? What's my sort order? I have to make something called an iComparable. I have to use this other class, a helper class, to create a structure so that I can sort with, almost like my own custom way of doing it. And we'll talk about that as we move forward. It's more of an advanced way of thinking. But for basic objects like strings and just decimals, or let's say, for example, names, a string, it's no problem. Search for the name, and it'll find that particular location and remove that one. Now, one thing it doesn't do is it doesn't store it anywhere. It just removes it, right? So if I was going to add things to the list and remove things from the list, it's different than popping and and the way we do that, where we return the value out of the list. We don't do that. So we'll talk about that as we get into lists more. Again, this is just an overview. I know I don't want to bore the crap out of you guys, but I want you to understand the basics of arrays and lists right now as we move forward. So here I'm adding a bunch of elements to the list. Okay. We can also initialize a list like this. Okay. Yeah. Here's what we're doing is when we have this, see the capacity is 3? You want to save memory. Yes, but it's going to double. It's going to double every time you do it. If you add more, so let's say I've added 3 elements to the list, but I've specified a capacity of 3. Once you add the 4th element, it'll double it to 6. We do. It's,
why not just go always by 1? And it's doubling whenever you pass it.
There's a reason for it, because sometimes we want to do it. Capacity is 2 reasons for capacity. 1, to limit memory, right? Like I said. And the other reason is when we want to figure out problems. Like example, I want to create a multiple of a number, right? So once I go beyond 3, right? If I want to do number systems, right? And I want to, let's say, do something like, I don't know, I want to talk base 3. Instead of base 10, like we're calculating things in base 10, I want to calculate your number in base 3, right? So I have the capacity is 3, and when I go to 4, it adds 3 more objects into the list, as an example, right? Automatically. They're empty. There's 3 more spaces. Now the capacity is 6. And when I do it again, the capacity is now 12. When I do it again, the capacity is 24. When I do it again, it keeps doing that over and over again. In other words, it adds in all the spaces that I need to create my number system. That's some of the reasons why we do this. Again, I've used it for that, right? It's not as common. That's the answer. It's not as common to do this with lists. Can we do it? Yes. Do we often do it? No. Yes. It's kind of like that. It's kind of like that. Same thing with. I mean, compression is a whole other. I like your thinking. Compression is a whole other issue. I mean, think about the way we do compression on different types of drives, right? NTFS is a good example. Almost all of us now use NTFS, except Mac guys. Mac guys don't use it. There's not an NTFS drive. It's totally different, right? And the compression ratio is really a lot different on a Mac than it is on a PC, right? I'll tell you right now, on average, not because the operating system is bloated and ugly, like Windows 10 I'm talking about, right? It's not that, right? I'm not saying that Windows 10 is bloated and ugly. I didn't say that, all right? I'm saying that the compression ratio is a lot different between Windows and Mac, right? So sometimes if you have a Mac that has standard stuff like images and stuff, the images are the same on both systems, right? But the way it compresses data on different drives can give you different capacities, right, as well, right? So, and we'll talk about that. That's kind of a topic from a hardware perspective, and compression. But a lot of this is this kind of stuff that we're talking about when we double and triple and those kind of things. The way we compress things when we have our algorithms to do that. Okay, sorry to muddle the water there, but that's the long answer. Okay, so one of the things we can do is with lists, again, you can see remove at. We do a lot of these removes and adds. Okay, I want to point this out. When we get to the database portion of this course, which we're going to be using Entity Framework and Link to connect to a database, okay? When we get to that part of this course, we're going to be using lists. So it's important for you to understand the list structure now, right? When you see a list, when I see the add keyword, that means I'm adding an object into the list, whatever that object is, okay? Whether it's a student, whether I'm adding in a person, a plane, an integer, a string, whatever I'm adding in, I use the add keyword, add method. And when I remove, I take stuff out of the list. That's the most important thing to understand right there. Other stuff, is all extra. And as you go down, you can see that there are other, it talks about different kinds of lists. I'm not going to go into sorted lists. This is just another structure with key value pairs. Again, a very interesting structure, and it would be a topic of another class, right? Because it would be something that we can do. It's in your book if you want to read about it, and it's another structure we use to solve problems. When we want to kind of relate, like I said, the name of a property, let's say example text, or the other properties like that, and then the value, key value pairs, right? Great when it comes to, you can also use this to connect to databases with a sorted list as well. Okay, so I'm going to skip through this. And I think that's really it for arrays and lists for the most part. They do talk about the queue class, and again, they have different methods of on-queuing, right? Adds a specified object to the end of the queue. Again, first in, first out. So the object gets added into the end of the queue, the end of the line, right? And then the object in the front of the queue. So I do a dequeue instead of a remove, right? And dequeue first object that you added in, which is kind of an interesting structure, especially if you're doing stuff like traffic. If you're simulating traffic, right? I have cars in a line, right? And I want to kind of on queue and dequeue cars in traffic. That's a great example. And we used to do that back in the day when I was doing computer science. We did a whole traffic example, traffic lights, right? Where we can on queue and dequeue, right? That's a good structure for that kind of thing. Again, we're talking about computer science here. Stack, right? Again, we have push and pop from the stack, right? So again, push, we add the specified object to the top of the stack, right? So first in, right, or last in. And then pop, we get the object from the top of the stack. So we pop it on the top and we take it from the top. So last in, first out. Why? Because the deck of cards, if I put something on the top, that's where I'm going to take it from. So if I shuffle the cards, whatever's on the top, I'm going to take it from. I'm going to take the next one and the next one. If I put it back on the deck of cards, it's going to be on the top of the stack. So I'm stacking stuff on top of everything. So that's how I'm taking it. The stack is like, think about it as an actual deck of cards that are building up, right? Almost like the top floor of the building. If Gorgimera is going through the the city and smashing buildings, this massive beast that's going to smash the top of the building first, right? I don't know if that makes any sense. For me, I don't know how I came up with that. You call the demon. No, I don't know. I don't know where I'm going with that. Call the demon, and it appears in the middle of the city. It's a massive demon. The heroes are all trying to fight it. Guess what? The demons are going to swipe the top of the buildings first, right? Stack, right? As opposed to, I don't know if you can remember that. Take something away from this discussion: demons and cities as opposed to stacks. Then you learn something in today. Right? It's fantastic. All right. As you can see, it's am I going to use this structure, stacks and queues, probably in our course? Probably not, right? But it's good to understand that those structures exist in C#. That's what I want you to take away. Seriously, it's not about that we're going to use them. The most commonly used thing we're going to use in this course are arrays and lists. Those are the two things we're going to do: arrays and lists. Okay. Very powerful structures because we can combine them to make bigger structures.
But cities and demons won't.
Cities and demons, no, definitely not. No cities and demons, and forgive me with my bad joke. Okay. Unity definitely. Cities and demons of Unity, we can do that one day, right? But not in this course. Shh, I'm recording. Okay. Anyways, otherwise, let's take a short break. I think we've kind of talked about a number of things that are boring the crap out of you all. I think we need to get some coffee, go for a walk, have a cigarette, call your girlfriend, all that kind of stuff, and then come back, and then we'll talk about other things. We'll actually do a demo. All right, so let me just stop this, and then we'll go from there.